Okay, so this is our last session. Just making sure that we have the environment set up as we wanted. We've got just reviewing what we've done so far. Starting from Alexi's Darknet YOLO 4 framework, we set up the environment to train on GPU on Colab. That included using the Cocoa weights pre-trained on YOLO v4. Then we used that framework to custom train our model. That included training on at least two classes, the deciduous and conifer trees. I've went beyond that to include I think total of 14 classes, and in the past sessions we looked at how, for example, we modified the data, the custom weights, the configuration file, the object.data and object.names to change the path to our classes that we've labeled our dataset to, and the classes that we've chosen. We went over again how to train and how to place all of that stuff into specific folders for the framework to make it easier for the framework to train on those images and classes. We learned about modifying the configuration file based on the number of images that we have. Sorry, not the number of images that we have, the number of classes that we have, including specific optimizations that we may or may not have chosen depending on the framework that we're using, depending on whether we're using Colab or not, depending on different aspects that we went over last time. So now we've and then as we went over last time, we looked at the transfer training from the pre-trained weights. Then so now we have all of this. We've trained it enough times, so now we have a decent enough accuracy for us to take that model and go to the next step, which is in this case just building a quick web app using Flask to look at the classifications and count the number of trees and other items that we've detected. So the items that we have are that we want to make sure that we have are our object.data, our custom configuration file, the last or best weights. So this is essentially would be the weights with the highest accuracy, a source image that we want to test, a specific threshold, and what we want to. And in this specific session, what we want to go over is that there are other flags or other aspects that you can extract out of these detections that would help us with the Flask aspect. We'll go over those in a bit. So now that we have our weights, we can convert those weights into a TensorFlow model. in this specific example, I'm not going to go over it, but I will show you the steps that you need to do. This specific repo has all the information that you need in order for you to convert the YOLO v4 weights into TensorFlow Lite, TensorFlow Lite, which also includes YOLO v4 Tiny, whether you want to stay with the darknet framework. So check that out. Pretty straightforward. You save the model from weights and you extract it as TensorFlow. With TensorFlow, the newer API means that you don't necessarily have one model. You have, I think, 2 or 3 files that you keep into one folder, and this is how you load your model. So keep in mind that this is the syntax that we're using when you want to call, if you want to use a TensorFlow model in a Flask web app, you want to make sure that you load the model in the proper way. Yeah, so this is what I did. You load the model as a folder, and you just double check that this is it converted correctly and it's in the right format, kind of thing. And the if everything goes well, you can see the convolutional layers in the essentially transferred from the YOLO v4 framework to TensorFlow. Now we go into the details about the web app. I'm just using Flask, and because we're using Google Colab, we need to install Ngrok. There are a few tutorials about how to get Ngrok up and running on Colab. There are different variations of getting this work depending on the version. So keep in mind that some tutorials on YouTube may be outdated, so make sure you're aware of that. So I also created a index.html and a style.css file because we need those 2 files for the web app. How I created those is a very interesting approach. I will go through that in a separate video because I think it's important that I show you that what I did there. But there's nothing there's nothing essentially unique about this. It's just index.html. It's pretty straightforward. You can design your web app in any way that you like, but in this specific, and for the purposes of this work session, we're going with the essentially with the bare minimum. We're going with really straightforward, just a way to choose your file from your local PC, upload it to the web app, and run your prediction model. Whether it's a TensorFlow or whether it's you decide to whether it's PyTorch or whether it's you decide to continue with the weights on darknet. All of them should work. Essentially using, I tried to make it as agnostic as possible, but you're free to use, I'll introduce you to the different ways, and you can choose whichever one you're comfortable with. So I have those templates, the index.html and the style.css saved. So I'm just saving them into the workspace, copying them to the workspace. And for the Ngrok, what you want to do is I will change this token. The newer version or the newer API or the newer versions of how you call it in a collab is that you need to specify the port number separately. You need to have a specific authorization code, and it provides you with a public URL. With the web app itself, the Flask web app itself, you call it in the same way. So this is just verifying that it's running as expected. So I just run this, and it provides you with a public link. For whatever reason, my Chrome does not seem to allow the Ngork for whatever reason. So I'm just using Chrome, Firefox on this. So as expected, it's running Flask on Google Colab. So it's working as expected. Well, this is the bare minimum of getting it to work, kind of thing. If you've converted your model to TensorFlow, kind of the initialization is pretty much the same. Other things that you need to consider is that you need to load the Keras model, the Keras libraries, the specific ones. You need to load the model in the same way that you converted it. We've looked at the cell above. Same thing. I'll go over the web app later on, but it essentially works in the same way that when you press predict on the web app, it goes here, whatever file that you've uploaded there, it will save it to your workstation, and it'll provide you with, like, it'll return predictions. This is not complete because I went over with the more agnostic approach, but you're free to play around with the TensorFlow approach, which is pretty much you just load the model and you just predict it, and you extract the classifications and the probabilities for each classification. Pretty straightforward, and you just return it in the predictions. We'll see what that looks like in the more complete example. So this is using YOLO v4 weights, which is to some extent very close to it. I want to say it's an agnostic process just because you'll see how I run it. Same kind of thing. A few more steps here. I'm using subprocess because it's just easier to run whatever you want to run, whether it's TensorFlow Lite, whether it's YOLO v4 or Darknet, whatever. It's just straightforward. And I'm going to be saving the whatever classifications or whatever detections on that image. You have the option of exporting those detections into a JSON format. So we're gonna save those as well, in addition to the image that we were gonna upload there. So same kind of thing. You initiate it with the authorization token. Post request. When you press the predict button, is that it's going to save it. It's going to upload it has the option of uploading the folder that you choose, and it's going to save it in the workstation. And this is just running the sub process, which is to some extent equivalent to running it like this, which we're used to at this point, kind of thing. So this is just running it in the sub process way. You wait kind of thing for the whole thing to run. And here, if you look at the you have the option of extracting the detections as a JSON file, and you have the option of saving it there. So this is what we're going to do. We're going to save it we're going to press predict. So it's going to save, it's going to run the model, it's going to save the predictions as a JSON. And we're going to open that JSON up and look at the predictions, extract the predictions that we want. So what we're going to do is we're going to extract the class name and the percentage probability or the confidence level that this is the class that it's detecting. Here we're just saying that I'm just trying to count it, or the easiest approach that I was thinking about. Pretty sure there are easier ways to detect it. The way I was thinking about it is just make it in a set. And this is what's going on here, which is there are different, for example, you'll see that, for example, let's take cars. If there are 11 detections of different cars, I'll just count set. What set does is that it looks at the 11 classifications of cars, and it just says these are just one, there's one unique element in here, and I'm just going to take it as one. I'm not going to take 11, I'm just going to take one. So this is perfect because we don't necessarily care about, so what we need to do is we need to count how many times classifications happen for each class. So if we have, for example, 11 cars, you want to count these 11 and put it as like link it to the car classification. Same kind of thing for trees, deciduous trees, coniferous trees, and the whole other classifications that that we've trained on, kind of thing. Yeah, same kind of thing. I'm just counting it, and finally I just put everything into a list. Pretty sure there's an easier way of doing this, more pleasant way, whatever. I'm just going with the bare minimum, easiest approach, kind of thing, anything that kind of works. So, and we return that list as the predictions list, which is everything that it predicted, the class name and the confidence level, and the counting how many times each classification happened. This would tell us the classifications, the overall, like all the classifications, and the count for each specific class it detected, kind of thing. So when we press that predict button, this is going to show up as text eventually. Let's go over the index file. It's just really straightforward. It's just a blank page with a title, image classifier in the center. And what's happening is that when you call the post request, what it does is it's going to look at the image, and it's going to do stuff to the image based on what you define in the app, which is what we've done. We're going to save it. We're going to save the predictions to the JSON file, open the JSON file, etc., etc., etc. That's all of that's going to happen upon pressing the predict button, and it's going to display if there are predictions, it's going to display them as text, and the specific call is the same one as here, which is the list that we've talked about. As I said, it's really straightforward. Just like plain background, just blue button, etc. So we're going to run this. Okay, so let's see. Okay, really straightforward. So what I'm going to do is I'm going to look for a test image. Let's go with this one, and I'm going to press predict. Takes a few seconds. And it listed the classifications, which are descending order of confidence, cars, as we previously saw in the mean AP, is that the cars have a higher probability of detection. That's fine. What we needed to do was more training. We discussed this. I also trained on a different framework, which is the YOLO v7 framework, and that was substantially better. But for the purposes of this work session, we started with the YOLO v4 framework, so I wanted to continue the whole thing with the YOLO v4 framework. So we've detected cars, we've detected conifer trees, deciduous trees, and the overall count eventually is deciduous trees, there are 7 detections. Cars, there are 13 different cars, and conifer trees, there are 4 conifer trees. So yeah, this is pretty much it. As I said, this looks hideous, but it doesn't matter. All we need to do was just extract the classifications and the count. Pretty sure there's a more neat way of doing this. You can change the HTML file to do more stuff with extractions. You can upload an image and the image will show here with the prediction right beside it, with the bounding boxes, etc. You can also display the bounding boxes. You can do a lot more stuff. As I said, this is the bare minimum kind of thing. All right, but yeah, so this is pretty much it. I'll go in a different video and we'll show how we've managed to do this, which is really, really cool. All right, so